Hey friends, we are in chapter 1 and we're looking at section 1, 2, variables and expressions. So let's take a look at our vocabulary for today. We've got 5 vocabulary words or phrases: algebra, variable, algebraic expression, defining a variable, and substitution property of equality. So let's go ahead and define each one. So algebra is a branch of mathematics that uses symbols, and that's kind of what we're going for. That's kind of what we're goaling for in pre-algebra. What we're going to do is start understanding what the symbolic representations are of equations and rules and things like that, and we'll also be using a lot of variables, which is another concept that we're going to talk about. The next word that we have is variable, and it's a letter or symbol used to represent an unknown value. So maybe last year you might see 3 plus a box is equal to 7. What goes in that box? Now, instead of using a box or a blank space to represent a number, we're going to use 3 plus f is equal to 7, and I'm going to ask you f is equal to what? All right, and so as our problems get more complicated using letters and things like that, we're going to have to learn different techniques in solving for a variable in algebraic equations. Which brings us to algebraic expression. So an algebraic expression, all right, is specifically, it's kind of like a numerical expression that we talked about last time, but it specifically has to have at least one variable in it. So examples of variable, so a math expression that usually contains at least one variable and one operation symbol. So I could have n, remember we're using letters to represent numbers, n plus 9, that is an algebraic expression. Notice I don't have an equal sign. Algebraic expressions do not have equal signs, okay? If it's an expression, it just represents something, and I don't have an equal sign because I'm not necessarily trying to solve anything, I'm just trying to represent something, all right? So 2n, or let's use a different letter, 2m minus 4 is an algebraic expression. T plus 7 over 9, you got it, an algebraic expression. So these are things that you're going to see and you're going to be working with and creating. So defining a variable. This is a very important step in translating a verbal phrase into an algebraic expression. So when you have problems that you need to define a variable, you want to stop, think about what's going on, right? Think about what you're being asked and define the variable as always representing a number. And you'll see that in a couple of instances when in our examples in a moment. Let's take a look at our next phrase, and this is substitution property of equality. We will be talking about other properties in mathematics, and properties are often written in this kind of a generic looking way. If two numbers a and b, right? So if for two numbers, I think if should not be there. For two numbers a and b, if a is equal to b, then a may be replaced by b. Sometimes they're hard to hold on to, right? Because it just seems like gobbledygook. But this is a generic way or a general way of expressing something that we know to be true. So let's go back and kind of unpack the phrase. So it says for two numbers a and b. So if you've got these two numbers, let's say some number a and some number b, if a and b are equal, then a may be replaced by b. Seems really silly. But if I told you that I know that the amount of money I spend on a cup of coffee, so that's what my variable is here. C is the amount of money spent on coffee. Okay? If C is the amount of money spent on coffee, and then I spent $7 on a fancy bagel, this algebraic expression represents what I spent, right? C, whatever amount of money I spent on that coffee, plus 7. What if I then told you that C is equal to $8, right? What this property gives me the ability to do, it says anytime I know that some number this in this, right? I've got these two things that are numbers. If they are equal, like we see C is equal to 8, I can now rewrite this expression by replacing C with 8. I know this seems like a whole lot of talk for something that you would have done automatically, but in math, we oftentimes create rules or make sure we have rules that are true, and properties give us the ability to say, yes, I can do this not just here, but anywhere. So I'll explain that more later. All right. So anyway, so now I can write 8 plus 7 represents the amount of money that I spent. And of course, I could solve or evaluate this and get that my answer is I spent $15, way too much at the coffee shop. And I didn't really do that. That's too expensive. All right. Let's go ahead and take a look at some examples. All right, so this is our vocabulary all together. If you didn't get a chance to copy it, you can pause it now and copy it all. But if you did, we're going to keep it moving. So looking at example 1, we're translating phrases into algebraic expressions. So here we've got A, B, and C, and we're going to translate each of the phrases that we see into algebraic expressions. Remember that algebraic expressions have variables in it. So our expectation is that we're going to have a variable. Before we figure out what the variable is, we need to define it given the situation. So you're going to read each phrase and you're going to figure out what is the unknown thing that they're talking about. Look, they're talking about coffee. All right, so here, the $10 more than the cost of a cup of coffee. Well, this is very similar to the little example we talked about. So we need to define the cost of the cup of coffee because that's the unknown piece. So I will say, let's use C again. C is the cost of a cup of coffee, So check this out. The reason why I'm writing this all out, because most people would write C is coffee. No, C is what? The number of ounces of coffee. C is the number of cups of coffee. C is the cost of. You need to define what the number is behind that variable. That's going to really help you all the way throughout algebra, pre-algebra, and algebra. So C is the cost of a cup of coffee. So now I know what I'm dealing with. And now when I rewrite this, $10 more than the cost of a cup of coffee, we know that more means adding. So we know C plus 10. Or in this case, more means add. Sometimes it might mean something else. All right, so let's take a look at this next one. Lisa had $11 and made $7 an hour babysitting. Well, that seems easy. 11 plus 7, right? Not quite. If she had $11, I think that's cool to say that she had 11. So that's going to be part of our expression, definitely. But she made $7 an hour babysitting. What is the thing we don't know here? The thing we don't know is how many hours she spent babysitting, and that's my variable. So if she spent like 1 hour babysitting, then she made $7. If she spent 2 hours, well, no, she made $7 on top of the 11. If she spent 2 hours babysitting, that would be $14 for babysitting added to the 11, and that's $25. So what we need to do is kind of think of a way that we can write an expression that would accommodate all these changes in hours. So hours would definitely be our the thing that is varying, that changes. So we need to define it. So I'm going to let H be the variable that I'm going to use. And H is not hours, but the number of hours. The number of hours babysitting. All right. So now that we've defined our variable, let's see how we can incorporate it into this expression. So we know she had $11, that's here, and she made $7 an hour babysitting. How can I represent $7 an hour? Think about what we just did. I said if she only babysat 1 hour, that was 7. If she babysat 2 hours, that's 14. If she babysat 3 hours, that's 21 extra dollars onto the 11. So what am I doing? I know you're screaming at home, multiply, and that's what I did. So I'm going to multiply 7 times H. In math, when you write in algebra, when you write a letter next to a number, that automatically means multiplication. If you don't yet feel comfortable with that, you can put a little dot or you can put parentheses around the H if you feel comfortable. But I'm going to leave it like that so you can start to get used to that. So that's 11 plus 7 times H. Let's look at this next one. 2 miles less than the car traveled. So 2 miles less than the car traveled. What is the unknown information here? Let's define our variable. The unknown information is how far the car traveled. And so I'm going to use T, not as car traveled or traveled. I'm going to use T as the distance that the car traveled. All right. Now that we've got that going on, now we can write an expression. So 2 miles less than. Now here's another place where people get a little confused. Sometimes we know less than means minus, right? Sometimes I see people do 2 minus T or T minus 2. So one of these is the correct answer. I want you to think about which one it would be. When I have trouble figuring out which one it is, I usually put in a value. I'll try to think about this in a real life situation. Let's say my car traveled 20 miles. What would 2 miles less than be? Would it be 2 minus the 20, or would it be 20 minus 2? And I hope you would say 20 minus 2, and you know that it would be t minus 2 as your answer. Okay, we'll work on problems like that again. Let's look at this one, example 2. So we have a situation where we're just evaluating an algebraic expression. So sometimes I think the examples I gave only had one variable, but you could have many variables and they can be different. So let's go ahead and take a look at what we have: y plus z minus 4, and we want to evaluate if y is equal to 12 and z is equal to 9. So the substitution property of equality told me that because these are equal, I can substitute it into this equation, and I'm going to do so. So y plus z minus 4 is what I want to figure out. I want to evaluate that. So since y is equal to 12, I'm going to place 12 in here. And since z is equal to 9, I'll put 9 here and subtract 4. Pulling back PEMDAS from last time, addition and subtraction are equivalent. I'm going to move from left to right. So I'm going to add 12 plus 9, and I'll get 21. And then I'm going to subtract 4 from that. 21 minus 4 will give me 17. And that's my final answer. Evaluation done. Let's see if we've got anything else cool to look at. We've got a couple others to evaluate, but I think we can handle it. Let's look first at what's going on. I just want to take an overview. This is 3 times s plus 7 times t. This is r times s divided by 12. Usually you might see it like this: rs over 12. And this is t plus the quantity of 25 minus 3 times s. So let's get started and see how we can handle these. I'll do this first one in red to keep it a little organized. So if I have 3 times s, I'm going to replace s with 6. Notice I'm using parentheses to indicate multiplication here. That is also a way that we can do it. And then I'm replacing the t with the 2. So when I handle this, I'm going to do the multiplication first. I get 18 plus 14, and when I add 18 plus 14, I get 32, and that's my final answer. Here I have r times s, and so that will be 4 times 6 in the numerator over 12. 4 times 6 we know to be 24 over 12, and that's going to give me 2. I was trying to use different colors, but I forgot about that. Let me do that here. And then finally, t is equal to 2. I'm going to add to that 25 minus 3 times the quantity of 6. So again, this is order of operation land, and what I need to do is make sure and do what's in the parentheses first, and the multiplication here. Let me do that. I think I got to do double parentheses there. That's what it is, because this is 3 times 6 and then, right. All right, so multiplication there means that I need to handle that first. So I've got 25 minus 3 times 6, which is 18. And then I'm going to do the subtraction before I come over here and do this addition, because there's parentheses around this. So 25 minus 8 is going to leave me with 7. And I'm going to add 2 to that 7, and I get 9. And that, my friends, is how you evaluate expression. Okay, so a company rents a houseboat for $200 plus an extra $30 per day. We're going to write an expression that can be used to find the total cost to rent a houseboat. So let's start this as part A. There is a part B. So it costs $200. That is a given fee, plus an extra $30 a day. What is the thing that varies here? What is the thing we don't know about? We don't know how many days. So we're going to define our variable. Let D represent the number of days. D isn't days, it's the number of days. I think you guys are catching on. So number of days. Your variable always has to represent an amount or numerical amount, so you want to keep that in mind when you're defining it. So 200 plus D, 200 plus D plus 30. How do we figure this out? Sometimes you got to think, how do the days affect this $30? If I stayed for 2 days, what's the extra payment? 60. 4 days, what's the extra payment? 120. So it looks like, what are we doing with 30 in the number of days? Looks like we're multiplying. So we want to make sure and represent that in our expression. So our expression is going to be 200 plus 30D. Let's go ahead and check out the last portion. So the last piece is that the Gregorian family, here's our equation from last time, or expression, the Gregorian family decided that they want to rent the houseboat for 6 days. What would the total cost be? Since we know the number of days, we're going to use our equation to input that information. So we're going to put 6 days here. We'll do a little bit of multiplication, and we get that they're going to spend an extra $180 and they'll end up spending $380 altogether. I hope that made sense to you. I look forward to seeing you, and I hope this is cool. Go ahead, after you finish this, you can get started on your work. Take it easy, guys. Talk